Alright, today we're looking at assignment 8.5, dice games. So notice there's two games here that you hopefully played. The first one is you're going to roll 2 die, and if your sum is a 3, 5, 7, 9, or 11, player A wins. If the sum is 2, 4, 6, 8, 10, or 12, then player B wins. So the first thing you should have done is told me which player you would want to be. In other words, which player do you think is most likely to win? Once you've done that, you should have played this game a couple times, and then, 20 times, and then you should have circled the winning player, either A or B. Then we have the second game here, which is the same idea, but this time you roll two dice, and if your sum is 5, 6, 7, 8, or 9, player A will win. But if your sum is 2, 3, 4, 10, 11, or 12, player B wins. So again, you should have told me which player you want to be. Then you should have played this game 20 times and circled the winner, either player A or player B. Then my next question here is either game fair? And to determine if it's fair, you first have to come up with a definition of fair. So the definition I typically use is that in order for a game to be fair, both players must have an equal chance of winning. So notice here I said explain why, including your definition of what a fair game is. So my definition is that each player has an equal chance of winning. And once you've decided that, you should have looked at these two games and decided whether or not each one is fair. So then we're going to look a little bit further into this. On the second page, I asked you for the empirical or experimental probability. That's the probability that you noticed when you played these games. So, for example, let's say that in game 1, I played the game 20 times and perhaps 8 of those times player A wins. So if player A had won 8 times, then I would say that the probability of him winning was 8 out of 20. And since we always simplify our fractions, I would simplify that down to be 2/5. So, in game 1 then, I would have had a 2 out of 5 chance of winning the game, assuming that player A had won 8 times. So that's your experimental probability, and you're going to have to do the experiment in order to get your experimental probability. But this second thing I asked you about is the theoretical probability, meaning in theory, how many times would you expect something to win? So for example, if I was flipping a coin, in theory, I would expect that about half the times my coin would be heads and about half the times my coin would be tails. So we want to know what the theoretical probability is that each player wins in game 1 and game 2. Well, to do that, we have to figure out how many possible outcomes there are. And you could say, well, look back here. There are 1, 2, 3, 4, 5 options here, and 1, 2, 3, 4, 5, 6 options here. So in other words, we have 11 possible sums that we could roll. But you have to be careful, because is every sum going to have the same probability of being rolled? Well, let's look into that. So I have some possible sums here. If I'm rolling 2 dice, I know I can't get a sum of 1 because I have my 2 dice. But I could get a sum of 2, a sum of 3, a sum of 4, a sum of 5, a sum of 6, a sum of 7, a sum of 8, a sum of 9, 10, 11, or 12. Now, let's think about what we have to do to get each of these possible sums. For example, if I want to roll a 2, I have to get a 1 on the first dice and a 1 on the second dice. There's no other way I can do it. If I want to roll a 3, I could get a 1 on the first dice and a 2 on the second dice, or I could also get a 2 on the first dice and a 1 on the second dice. Now, if that's confusing to you, let's imagine that my dice are colored. I could have a red dice that gets the 1 on it, and I could have a green dice that gets a 2 on it. Or I could get it the other way around, where my green dice gets a 1 on it, and my red dice gets the 2 on it. Either way, I have a sum of 3. So there's actually 2 ways I could do that. Well, to get a sum of 4 then, I could have a 1 on the first dice and 3 on the second. I could get a 2 on the first and 2 on the second, or I could get a 3 on the first dice and a 1 on the second. So there's 3 ways that I can roll a 4. If we continue this pattern, in order to get a 5, I could have a 1 and 4. I could have a 2 and 3. I could have a 3 and 2, or I could have a 4 and 1. So keeping that in mind, take a few minutes to go ahead and fill in the rest of this table, then check in with my next video.